So I wanted to give you guys a bit of an easy lesson on how we actually do what we do. So you don't need to understand this graph here on the left, other than the very top it's big, right, and at the bottom it's small. The funnel goes from big to small. And there's a dotted line here at the very top. And if I was giving this talk 10 years ago, 15 years ago, we wouldn't have had a dotted line. And that dotted line separates things that we have never seen, untested, and then things that we actually test. And that's with genetic technologies. So what we do today, just to start the process, is we actually make a cross. I don't know if you've ever, you go in your soybean field and you see the flowers. They're really, really small. To make a brand new variety, you have to choose two parents, mom and dad, and then you have to cross them. So what you do is you take some tweezers, you pull off the petals, and it's hard to see here, but there's white. Those are the anthers where the pollen is, and then there's a little white stigma right inside that white spot. So you have to do that really carefully. That takes about 15 minutes to get the petals off there without killing it. Right? Then you take pollen from daddy soybean on the other side. Take a flower, take just the anthers, and you dab it on right on that stigma, and you make a pod. So 15 minutes to do one. Right? So I can do maybe 4 an hour. If I'm really good, only 2 of those live. Right? So half of them die because I stabbed it wrong or whatever. And then each one that is actually successful, I get 2 seeds. So I can make like 4 seeds an hour. That's why we do not sell hybrid soybeans. Right? Not efficient. So anyhow, you make that cross, and that's a hybrid. So we don't sell that. We send that to Puerto Rico, and they can grow 3 or 4 cycles a year. They just keep growing soybeans down there. You grow the soybean. Unlike corn, which is easy to pollinate, soybeans are really easy to self-pollinate. All you just leave them, and they do it themselves. So they self-pollinate. So they and then we grab those seeds, and those are called F2s. Not important. We grow those, and then we self those, and we have F3s. And how we make a new variety is we just take a plant and thresh only the seeds off that one plant. That's a new variety. Okay? We create, essentially we create over 2 million new varieties a year. Okay? We can't see those in the field. It's just way too many. But we can test them. And so that's what that dotted line comes in. We create all these new soybeans, and we genetically test them. So we take either a leaf chip, seed sample, and we test the DNA. We pull the DNA out of that, and we can use genetic markers. And so this just represents, if you can see, blue and red. So blue would mean I have 2 copies of my gene. Red means I have 0. Okay. So cyst resistance. It's a single gene thing. Flower color. Okay. Frog eye leaf spot. Right. SDS tolerance. Chloride. Phytophthora genes, all these genes that we want to include in our new A-series soybeans, I can pick them right there. So the red ones, I would say, okay, those have, the blue ones, those have my Phytophthora 1K gene, which means fewer plants die in those bottom soils when Phytophthora hits. Fewer plants die. That's good. That's yield. So I'm going to pick those, and I'm going to throw away all these others that don't have it, right? And I'm going to do that for other genes, and just keep going down the line. So you take that couple million plants, and you throw 80% of them away, 90% of them away. And you only bring home maybe the 30,000 that have the right genetics. So that's the difference between untested and then tested. So that next year, I can actually see them in the field. So here, I don't know if you can see, there's a combine, and there's these really small plots. Those are actually single row plots, because on each new variety, you only get about 60 seeds. So I can only plant about 5 feet, 1 row in 1 location. So those are all going to be in one eco. So all these are sisters. Combine cuts them. So all you can do is see whether are they too tall, too short, they fall over. Sometimes you get some disease in there, and you get 1 yield data point from the combine, and you make a decision. And so you might have 30,000. You might only choose 3,000 are the best. They stand upright, good disease tolerance, and they yielded enough. Okay. So now you only have maybe 3,000 individuals. Then you have enough seed to go to 8 to 10 locations, and that's over a broad region. So now all of a sudden I can go Kansas and Missouri, get a pretty good data point on yield, maturity, some better agronomics. Take those 3,000, turn it into 200. That's the next stage down here. Those go to more locations, maybe 25, 30 locations, same process. Then they go to impact. So some of you guys are probably familiar with impact plots. That's when the R4s. Going to those maybe go to 150 locations depending on maturity and those types of things. So at that point, you're down here with only a couple choices, but you've got a lot of data. So as a breeder, I think the success you have is how you manage this inversion here. And what this means is when we get down to the bottom and I've got 150 data points, easy to make a decision. This one is either better than what I'm selling or it's not. Really easy to make that decision. But I only have like 2 choices, right? It's up here where all the magic happens. When I got a lot of decisions to make, I got 3,000 decisions, and my data is only so-so because I only have 6 reps of that data. So that's when you really make your progress. And so that's where the breeding cycle right there. It takes 7 years to go from that cross, okay, to actually offer something for sale. And as a breeder, we look at a lot of data, and we really make sure that anything that we actually sell is better than what we are selling today. So that new R4, it doesn't get advanced unless it's better than what we've got today. All right?
On 7 years, is that truly physically 7 years, or is that 7 cycles?
It is 7 physical years.
7 physical?
Yeah, so we actually have a lot more cycles that happen in Puerto Rico, in other places, because we take those off-cycle things and we increase seed, we do purification, exactly. That would have been 14, 15 years, 30 or 40 years ago probably.